So I want to talk briefly in this video about something called the additive property of equality. And what this basically says is that if you have A equals B, then you can add any number that you want to both sides to one side of the equation as long as you do it to the other. So this would imply that A plus N is equal to B plus N when the N is the same here, right? Okay, this also works with subtraction as well. You can do A minus N is equal to B minus N, okay? So in practice, let's say we have something very simple. We have something like 1 is equal to 1, okay? Obviously true. But this is also going to allow us to do, say, 1 plus 3 is equal to 1 plus 3, or we have 4 is equal to 4, okay? So let's see how this works in a little application here when it comes to solving equations. Here we have -2 plus x is equal to 4, okay? So the whole goal in solving equations like this is you want to try and isolate this x variable all by itself. Okay, so we want to see if we can move numbers around in order to do that. As a matter of fact, this is going to be a recurring theme throughout this class, is seeing if we can manipulate different equations to try and isolate the variable all by itself. So here's a pretty simple example of that. So in order to do that, we want to see if we can move this -2 over to the other side. All right, so let's go ahead and add 2 over here, and that would cancel out this -2. But since we added it to the left side, we also have to add it to the right side. That's going to keep our equal sign equal. All right, so these will cancel, and now we're going to end up with x is equal to 4 plus 2, or we have x is equal to 6. Okay, and what's really nice about this is that you can actually go back and you can check your answers. You can take this 6 and you can plug it back into your original x here. So here we would have -2 plus 6 is equal to 4, okay? Or we know that -2 plus 6 is 4, so we have 4 is equal to 4, okay? So that 6 would be your answer here. Now let's try this one, x plus 3 equals 5. Remember, we can subtract as well, so our goal here is to isolate the x variable, okay? So let's go ahead and take 3 away from this side, but since we did that, we also have to take 3 away from this side, and that's going to give cancellation here, but then we're going to have x is equal to 5 minus 3, or specifically x is equal to 2, all right? And you can take this 2, plug it back in, and confirm that in fact 2 plus 3 is 5. Okay, now let's take a look at a slightly harder example. Here we have -1/4 plus w is equal to 1/8. Okay, so again, we want to isolate w by itself, so let's add 1/4 to both sides of this equation. That will cancel here. So we're going to end up with w is equal to 1/8 plus 1/4. Okay, so we can see here that 8 is a multiple of 4, so we can very easily write 1/4 as a fraction with a denominator of 8. So we can write this as w is equal to 1/8 plus 2/8, which is going to give us 3/8. Okay. Let's do one more. Here we have x plus 2/5 is equal to 1/3. Okay, again, we want to isolate x by itself, so let's take 2/5 away. Okay, and that's going to give us x is equal to, after these cancel, we'll have x is equal to 1/3 minus 2/5. Okay, so here, remember we have to see if we can find a least common denominator. So let's multiply this left fraction here by the right side denominator over itself, and the right side fraction with the left-hand denominator over itself. So this is going to give us 5/5 times 1/3 minus 3 over 3 times 2/5. Okay? So here, we're going to end up with 5 over 15 minus 6 over 15. Okay, because we just multiplied straight across both numerator and denominator. And this is the same thing as 5 minus 6 over 15. Or we end up with negative 1 over 15.